In this video, we are going to take a look at Unit 8, Lesson 3, which is about sample spaces. By the end of this video, you will be able to list out a sample space of an experiment and then use it to explain the probability of an event. So on page 271, in this first activity, you are going to list out the sample space when rolling two standard number cubes. And remember that number cubes are just die. So they are going to have a 1, 2, 3, 4, 5, and 6 on each side. So one on each side. So you're going to roll these two die and list out all the possible outcomes. One of those outcomes is that both die have the number 1 on them. And so I would just list that out as a 1, 1. So go ahead and list out all the other possible outcomes and determine how many items or outcomes are in this sample space. Then come back to the video. So you could have tackled this multiple different ways by listing out and doing maybe a table. You could have done a tree diagram. You could have done an organized list. One thing for me that I did was I thought about the fact that if I rolled the first die, that one could be a 1. So then what could I get if I rolled a 1 with the first die? Could roll a 1 with the second, like we listed already. I could have rolled a 1 with the first and then gotten a 2 with the second. So I could have gotten each of the other numbers. So I just wrote down 6 ones. And then I listed out all of the options for the second cube. So 1, 2, 3, 4, 5, 6. And those are all the options if my first die was a 1. Then that could happen again when I roll a 2. So if I rolled a 2 on the second die, I could have rolled a 1 through 6 on the first. On the second. And so I just listed all of those possibilities out. And then I kept going and ended up with this as my sample space. And so I ended up with 36 outcomes, which made sense since each option, so the first die had 6 and the second die had 6. And so 6 times 6 gave me 36 possible outcomes. Again, certainly there's other options on how you wrote out this sample space. Let me just take a look at what a couple of those would start looking like. So maybe you looked at doing a tree diagram. So you listed out the 1 and then said this 1, after you roll a 1 on the first, you could have rolled a 1, 2, 3, 4, 5, or a 6 on the second. And then you could have done this again for each of the other numbers. Roll a 2 on the first, could have gotten 1 through 6 on the second, and so on. You could have done a table, which is basically what this looks like. So you could have done a table where you listed out the number options. So on the first die, I could have gotten a 1, 2, 3, 4, 5, or 6. On the second die, I also could have gotten a 1, 2, 3, 4, 5, or 6, and then filled in all the cells here. So if you kind of think about these commas as cells, but you could have done it that way as well. So multiple ways to tackle finding the sample space here. And so now that we have the sample space, what is the probability of rolling a 2 on the first die and a 2 on the second die? So we need to roll double 2s. And we see that here once out of 36 times. So there's one way to do that out of 36. What is the probability that the first die is a 5? So the first die is a 5 is this whole row right here. So we see that there are 6 times that happens out of 36 total possibilities, which simplifies to a 1 out of 6 chance. So either of those are considered the probability of rolling a 5 on the first. All right, then we're going to practice doing sample space for these spinners. And you want to take a look at how Diego, Tyler, and Lynn each looked at writing out the sample spaces. All right, then in activity 3.2, we're going to take a look at how Diego, Tyler, and Lynn all looked at sample spaces. All of them did it differently for the experiment that we spin each of these 3 spinners. So Diego makes a list of the possible outcomes, so listed out all the options. Tyler made a table. So he started by making a table for the first 2 spinners and listed all the outcomes. Then he took those outcomes and listed those against the final spinner to get his total outcomes. And Lynn decided to do a tree diagram. So did the first spinner, second spinner, LMN, and then that third spinner with the 4 options to get her sample space. So in looking at those 3 different ways to do sample space for the same event, okay, so they are all doing, or I'm sorry, for the same experiment, answer the questions on page 272 and 273 by looking at their sample spaces, and then come back to the video. So how many sample spaces, how many outcomes are there in the sample space for each experiment? So you could count them up. I chose to count it from Tyler's because then I can see that there's 6 options on this side and 4 here. So I just multiplied instead of having to actually physically count to 24. One of the outcomes from Diego's list is BLX. Okay, so you can see BLX here in Tyler's list. Where does this show up, or I'm sorry, in Diego's list? Where does this show up in Tyler's method? So where is BLX in Tyler's? And remember that this table is Tyler's. So BLX is right here. And where does it show up in Lynn's? So we would follow from B to L to X for Lynn. So it's along that path. When spinning all 3 spinners, what is the probability that they point to the letters A, then N, then Y? And explain your reasoning. So A, N, Y we see here in Diego's, here in Tyler's, A, N, Y in Lynn's. So that shows up once in each of theirs. So it's a 1 out of 24 chance, whichever one you look at. That's 1 outcome out of the total of 24. How about that they point to the letters A, M, W. So here's A, M, W, A, N, Z, or B, N, W. So I'm just going to circle in Tyler's method here. But this time we see 3 options. Okay, 3 outcomes for this event. So 3 out of 24 would satisfy this. Either this one, or this one. That's 3 out of 24. So we could simplify that to a 1/8 chance. Then what would happen if a 4th spinner that has 2 equal sections labeled S and T is added? How would each of these methods need to adjust? So if we added in another spinner, okay, how would each of these change? And so through this list, we see here's, kind of the split of the options because these are all the ones that started with A. So now each of these would have another set because we'd have to add an S at the end of each of these and a T. Also here for the B, okay? So you'd have to double this. So you could add in, okay, add an S at the end, then a T at the end. So you double these spaces, you'd end up with 48 outcomes. Whoops. So for Tyler's, okay, he would end up taking all of these 24. And let me just go on a different screen. So then he would list all 24 of those out here, and then he'd do S and he'd do T. So he could add an S at the end of each of these and a T at the end of each of these. So he'd have 24 options here, 24 options here, and he would end up doubling his sample space as well to 20 or to 48 outcomes. And Lynn's doubling would come at the end because she would just add on 2 branches to each of these. So now we would do S and T from each of these, which would double all of this. So she'd have 2 more branches coming off of each. So how many cells will there be for the new method? 48 again. How many paths will there be in Lynn's? 48. And then which method would you use to solve the problem? That depends on which you like better. So do you like the organized list? Does it make sense? Are you able to make sure that you have all the options? Does a table feel more comfortable? Or does a tree diagram feel more comfortable? Okay, so any of those are options for you to use. Doesn't matter which one, just matters that you use one that's comfortable for you. So are there benefits to each representation? Certainly. So, the organized list probably takes up less space. So you're able to just list them out, but more likely that you would miss something if you're not careful about how you're doing it, if you're not actually doing a methodical, organized way of writing them all down. The table in the tree diagram, you can see each of the options. So you can see that you've got these cells to fill in and you know where each one is coming from. So this first one's going to be AL by W, then AL by X, then AL by Y. The tree diagram, you can see each of the spinners. So here's the first spinner. Here's the second spinner. And then you've got the third spinner happening. So you can see each of these happening. So then you're able to more easily notice that you have all of the outcomes. And so why you choose to do one over another is going to be dependent on how comfortable you are with each one. So if you are very comfortable with one over the other, you'll probably default to choosing that one. As you get more comfortable with the 3, you might flip-flop between depending on what the situation is calling for. And then how could you determine the number of new outcomes without writing out the sample space? So without writing this all out. So for this one, we said we added an S and a T, right? So this new spinner had 2 options. So 2 new outcomes. And so that's going to double, okay? Or we multiply by 2 because we added in 2 new outcomes. So you just multiply by the new number of options. All right, then in activity 3.3, which is on page 273, you're going to practice writing out sample spaces. So now you've seen 3 different methods by Diego, Tyler, and Lynn. So there are 4 situations on page 273. So go ahead and list out all possible outcomes if you're in class. Certainly do this with a partner and list out all the possible outcomes of the experiment for 1 through 4 using the representations that you just looked at by Tyler, Diego, and Lynn, and then come back to the video. All right, so we're going to take a look at these 4 sample spaces, and you could have, again, done whatever representation felt most comfortable to you. You don't have to have done the same one as me. So I chose in this first one where we're rolling a number cube, which is the numbers 1 through 6, and then flipping a coin, which is heads or tails, to do a table. And so each of these numbers ended up with a heads, each of these numbers ended up with a tails. And so my sample space is these 12 orange options here. You certainly could have, written out, if I roll a 1, I'm going to get a head or a tail, and done a tree diagram. And if I got a 2, I'm going to get a head or a tail. And you could have kept going that way as well. 4 coins are flipped. So I chose to do a tree diagram in this one because then I could see each thing happening. So here's my first coin flip, my second coin flip, my third coin flip, okay, to getting to the fourth set. So this one just helps me see that I had 1, 2, 3, 4 coin flips and making sure that I got all the options. So with the first coin flip, it could have been heads or tails. Then we flipped that one for a heads or tails, and then so on. Each one could have flipped to a heads or tails. And so then we ended up with 2, 4, 6, 8, 10, 12, 14, 16 outcomes here. Number 3 was 2 spinners being spun. And so I just assumed that R, B, G, and W were colors. So red, green, blue, and white. And so I kind of used that as I was writing them out. But I put red with each of the 5 numbers, G with each of the 5 numbers, B with each of the 5 numbers, and W. So I did an organized list that time to get my 20 outcomes. And then in number 4, it says a class block is chosen from 1, 2, 3, 4, 5, and then a subject is chosen from English or math. So I listed out each of the blocks with the E and then each of the blocks with the M for English and math. So I did an organized list that time for the 10 outcomes. So then let's look at some different probabilities that could happen here, or some different, let's calculate some different probabilities here. So in this first experiment, and I'm going to get rid of this, but let's look at the probability. So what is the probability that we got a heads in this one? So probability that we got a heads in this one is half the time. So you could maybe notice that your heads are in this first column. That's exactly one out of every 2 options, or 6 out of 12. So if you're using this sample space to explain your probability, it's that you see the heads happening half of the time. Okay, so I just simplified it right away. You could also say I see heads in 6 out of the 12 outcomes. So heads appear 6 out of the 12 total times. That simplifies to 1/2. And so depending on your representation, maybe it was the heads shows up in half the branches if you did a tree diagram. For number 2, what's the probability that we get exactly 3 heads? So then I could look at here. I know I need to flip a head, 3 of them. So if my first 3 flips are a head, then my last one would need to be a tails. So there's one time where it went head, 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 tail. I'm just going to list them out over here, the ones that qualify as a good outcome. So then I could have flipped the first 2 coins as head, then I would do a tails and then back to a head. So I could have gone head, head, tail, head. Could have flipped a heads first. So that's 1 head, then tail, and then 2 more heads. So heads, tail, heads, heads. So then the last option would be that I flipped a tails on the first, and then I did heads on the next 3. So tails, heads, heads, heads. So that means that 3 heads happened 4 out of the 16 times, or 1/4 simplified. How about in number 3, take a look at what would the probability be that we got R1 or R2 or G1 or G2. What would the probability of that be? So then we could say, all right, we see R1, R2, G1, G2. That's 4 options out of 20. So we know the whole sample space is 20, and that's 4 outcomes, which simplifies to 1/5. So how do we use sample space to calculate probability? So sample space is kind of like our bottom number, right? It's our total outcomes. So it's the total possibilities. And then we can count the number of times that an event is happening. We're able to physically see it and circle how many times it's happening out of the total. So it helps us to see everything. And then how does using a tree diagram, organized list, or table help you to answer questions about probability? Same idea. You can actually see all the events or all the outcomes so that you can figure out which ones are in your event. So see all the outcomes, and then you can see them, you can circle them. Okay, you're able to analyze how many events are happening for the question you're being asked. And then if you're watching this video online, you don't have a partner, so we'll skip that one. And so hopefully now you see that you can create organized lists and tables and tree diagrams, and hopefully you understand how to use those to calculate probability. You can certainly check your understanding with this lesson by doing the lesson 3 practice problems. Remember that I have a video going through those as well if you need help. And here is the cool down for this lesson that you should work on and complete. And if you have questions about this or you're struggling with it, be sure to reach out to your teacher.